Hey, what's going on, guys? I'm Eric, and this is my project video for robot learning. For my project, I developed a reinforcement learning model to play Pokemon and investigated how a curriculum-based approach can be used to improve the training process. First of all, if you're not familiar with Pokemon and its in-game battling system, I'll give a brief rundown. Within a battle, two trainers show down against one another, each bringing 6 Pokemon. These Pokemon face off 1v1 until all Pokemon from one side have fainted. Battles occur in a turn-based format where both players make simultaneous moves. During a turn, a player can generally select one of their 4 moves or switch their current Pokemon. This relatively small action space makes battles easy to understand, yet AI has failed to master Pokemon. The best bots that play Pokemon on the popular battle emulator site known as Showdown have only climbed to around the top 10% of players on the ranking ladder, without even considering team building. Why is this? With over 1,000 Pokemon, each with unique abilities, move pools, EV/IVs, and items, the number of starting states for Pokemon alone far exceeds that of traditional 2-player games like Go or chess. Oh, but you say the number of viable unique team comps is much smaller, and yeah, that's true. And the brain strain factor isn't that large given the small action space. Pokemon can't possibly be that difficult to master. Compared to other strategy games, however, Pokemon differs in 2 key ways: its inherent randomness and partial observability. Pokemon contains a luck factor, that's part of what makes it fun. Damage is calculated randomly within a range, moves can miss, and they have secondary effects that only apply some of the time, like burn. However, the stochastic nature of the game causes the game tree to explode because one pair of actions can result in a bunch of states. The other problem is the partial visibility for each player. You don't know the items, moves, or abilities of a Pokemon until their effects are applied on you. This is an issue for a reinforcement learning model, which relies on a complete and accurate representation of the state space. Obviously, this is a pretty daunting mountain to climb, but I'm on the quest to be the very best that no one ever was. So basically, I wanted to investigate how curriculum learning can be applied to this Pokemon model. Curriculum learning is fairly intuitive and basically is just a training approach that is structured in a way similar to how humans learn. Uh, this is the overview of the algorithm. I use proximal policy optimization. It's a policy gradient method that has just some nice optimizations. Primarily has a clipping function that limits how much the objective function can change, which is good for stability. There's also a lot of tunable parameters for stuff like exploration and keeping the value function accurate, which is nice. This uses an actor-critic framework, which I'm assuming you all are familiar with. So basically, first the enemy trainer is selected for the model to play against. Then we roll out the trajectories, compute advantage functions, update actor-critic, and over time, the difficulty of the opponents is scaled up. So what were the results? They were sort of meh. I was gonna walk through a battle. Holy crap, it's loud. But I think I might be cutting it a little close on time, so I'll just let it play in the background. The model could consistently beat both a player that made random moves, okay, it should, and a player that always selected the move that it did the most damage, but it struggled against a player using heuristics like setting up entry hazards and using boosting moves. It was heavily focused on damage now and didn't like switching or dealing non-damaging moves. Obviously, there's a bunch of improvements that can be made outside of just training longer on better hardware that I grouped into 3 broad categories. The first being improving features. We want there to be more features, but we just don't want them all to be like one-hot encodings for every Pokemon ability. So one idea I had was to contextually embed move and ability descriptions, sort of like what LLMs do. Another was adding an LSTM layer to predict the hidden states. The second improvement, which is only really necessary when the model is better, is using an RNN for the policy network to help pick up on like long-term strategic decisions. Like basically my model would be exploited because it uses the same move over and over again a lot. The final improvement I could think of was improving the curriculum learning for specific Pokemon battles could be developed to teach the model certain skills. Battles could be made where you need to have a good understanding of entry hazards or status move utility to win. You could develop these skills like sequentially or potentially even in parallel using policy distillation. What's the time? Major takeaways are Pokemon is fun, but it's hard, and that curriculum training paradigms are pretty useful and should probably be employed for reinforcement learning.